I'll give it a couple more minutes, let everyone trickle in, and then we'll go ahead and get started. And today's topic would be securing Industry 4.0 as we get into the era of connected assets. And we are increasing our capability of doing analytics, but we are bringing in some cybersecurity challenges that are both interesting as well as sometimes challenging for different groups. And that would be our focal point of today's discussion. Okay, I see that we are 1 minute past 3 Central Time, so I'll go ahead and get started. So, like I mentioned, today's topic is securing Industry 4.0. Now, we like to call it that this is the industry of the future. This is the new era of connected assets where everything wants to integrate using APIs, everything wants to talk to the cloud, go through different network zones, and we want to see a lot of data, even in our home. If you think about it, we want to see the data of of our IoT devices that we have on our phone. And like I said, that brings some cybersecurity challenges that is interesting and sometimes really challenging to counter in an industrial environment. So I am Dr. Rishabh Das. I am an advisory specialist master at Deloitte. And my primary job at Deloitte is to protect clients, both government and commercial clients, who are involved or who are using critical infrastructure, like maybe nuclear power plants or maybe ports who are transporting different containers, anything that you name it that has PLCs or sensors on it. I work on securing that. And part of my research career before my employment with Deloitte also revolved around embedding security principles or security components like embedded intrusion prevention systems inside programmable logic controllers or ruggedized computers that usually help run these industries. And before Deloitte, I have also worked for an oil and gas company as a control system engineer. So I have seen how these vulnerable system works on the field. And then I have extrapolated some of my knowledge that I gained as a control system engineer uh, in the field of cybersecurity. Now, before we discuss security challenges or defensive measures around IoT or Industry 4.0, um, what is Industry 4.0, right? When we generally talk about Industry 4.0 or any related topic, you will see the word smart, right? People will talk about smart cities, people will talk about smart manufacturing, smart power grids. And what they actually mean when they talk about smart stuff is it is highly interconnected process. So every asset wants to talk to other assets, provide data, get feedback, and get analytics engine running. It also talks about factory monitoring framework. So smart grid or let's say a smart manufacturing plant will have that whole influx of data coming in from the sensors. It will go to the cloud. And then you as an operator or you as an analyst would be able to see and monitor what's going on in the plant. And you don't have to be in the plant. You can just access the cloud dashboard from almost anywhere. Now, it also brings in the capabilities of data analysis. So once you monitor what's going on in your plant, you can leverage the compute capacity or high compute capacity of the cloud and run an entire optimization framework. So, for example, you can look at your manufacturing rate at a manufacturing line and then optimize the performance of certain cells or certain components of that line and create products that are better optimized or optimize the entire cycle time of the manufacturing line and optimize the process and create greater output. So you are helping drive the business impact or economy over time. It, of course, has a control system. So it has a set of assets that are controlling various parts of the manufacturing plant. And then finally, an automation framework. So all of these data coming together, optimizing, and then creating an impact that translates to higher output or safer process, things like that. But overall, when you think about Industry 4.0, you're talking about five broad topics. So you will see a lot of connected devices, which I've highlighted many times. You will see data sensing capabilities. So data that are captured by sensor would be processed by uh, operational technology systems and would be sent out to either local servers or cloud. You will see modern communication frameworks like 5G and 4G that are getting integrated um, into these infrastructures. Then there's analytics. So all of this data comes in, they give you beautiful charts or provide statistics, provide health metrics that ultimately drive business decisions if we are to secure it in a certain way or what needs to change in the process to produce a higher output. And then ultimately, all of these connectivity, data, everything drives the data value, right? So you get value out of the data. Now, before I go into the other portions of this presentation, um, I would like to launch a poll to gauge the audience. And let's see how familiar you are with the IIoT security topic. So I have three options. Option one is I've never heard about that. And option two is actively involved in the field. And then option three is you're a security expert in this field. And let me know if you do not see the poll, because this is the first time I'm using Hopin. Okay, so you see a different question. Okay, so both polls are live together. So I had a second question. So unfortunately, both of them went live. But the first question was, like I mentioned, I wanted to gauge the audience, and it necessarily asked this: How familiar are you with IIoT security in general? And the second question that you guys, it was prompted first in this presentation is how or can a security auditor use an active scanner to fingerprint OT devices? And the response is false, because you will see in the later part of the presentation, we talk about how IT security is different from industrial security and how the controls and tools don't always work on both of those two worlds. Um, but I'll go ahead and talk about the other parts of the presentation. So let's talk about some Industry 4.0 security trends. Why is it important, right? So in the field or when we work with clients, we see many vulnerable systems, many vulnerable assets. There are network architectures that are not well built. And going through some statistics that you can easily get online, 40% of the industrial sites have at least one direct connection to the internet. Why is that a problem? These devices, like embedded computers or PLCs, these are not meant to be internet facing and are very vulnerable to some of the exploits that are readily available to the hackers or malicious actors. 16% of the sites will have at least one wireless access point, and that gives attackers who are maybe outside the facility, they can connect to that Wi-Fi or wireless access point and get access to critical infrastructure that might be controlling power grid accessories, or maybe something like even more critical like a nuclear power plant or even manufacturing lines. They can disrupt those kind of functionalities. Then 57% have weak antivirus protection. In fact, a lot of them don't even have antivirus. So you go into these industries that are getting connected to the internet, and they don't have the basic cybersecurity requirements or cybersecurity technologies like AVs installed on their endpoints. And almost 84% have remotely accessible devices. So there is a very good website called Shodan, and that website is basically a search engine for all of these devices, IoT devices, as well as industrial devices that are directly connected to internet. So you can go in and you don't even have to do customized queries. You can just say traffic light or uh, put in a name of a vendor that makes traffic lights or maybe network interfaces, and you will get a good list of items with lots of details like MAC addresses, IPs, that is almost, you know, pingable from any parts of the world. So very vulnerable and accessible devices that can compromise your infrastructure. And about 69% have security gaps in the areas that, like plain text password. See it very often using SNMP version 1, or using protocols like FTP, or using OT protocols like Modbus, which are inherently not designed with security in mind. So a lot of plain text protocols going through. And in case an attacker gets access to these network communications, he can easily draft out or easily monitor or eavesdrop what's going on the network, and then compromise you over time. And this was my second question. This was already answered by the audience, so I won't launch a poll again. But a security auditor cannot use an active scanner on an OT device. And that holds true for kind of other IT tools as well. In a lot of cases, antivirus that works on IT environment might not be the right fit for Industry 4.0 or for OT devices, primarily because some of the OT components does not play well with these AVs. And that's kind of true with any IPS technologies that works on IT might not work well on OT. So there is a whole set of OT vetted tools that are usually effective on the OT side. Now, I wanted to draft out the difference between IT and OT, and the priorities of the security technologies are different, right? So if we look at performance priorities, OT strives to get a real-time response from the system. On the other hand, financial sector or IT departments, which are just running the business side of any company, they rely on high bandwidth and they tend to be delay tolerant. Similarly, for patch management on the OT side, usually engineers have to go through extensive testing. So you cannot just go in and update a computer on a nuclear power plant or in a manufacturing plant, because that will cause disruption, which means loss of time on production. Uh, in fact, it is even worse because it can cause loss of life. If a critical process stops, your nuclear reactor might not cool or might cause other types of disruption that can cause human loss of human life. So that is very, very critical and something to keep in mind when you are maintaining uh, a OT or Industry 4.0 infrastructure. Now, in case of IT, yes, it is inconvenient if your computer goes down, but usually, these type of rigorous testing, it's not necessary because you can update the computer. If it does fail, you have a fair bit of flexibility over there, and you can back up or roll back to unknown steady state. In terms of availability, uh, OT again requires to be up all the time. These are critical processes, so you cannot easily schedule downtime. On the IT side, though, you can have multiple systems be redundant, and downtimes are scheduled. You will sometimes see your company's website going out for the weekend, so that happens all the time. But again, a nuclear power plant or a manufacturing plant, they tend to keep running for years and sometimes decades. So I've seen computers that are up for almost 2 3 years and they haven't been even restarted. So that's something to keep in mind. And on the risk side, the OT revolves around human safety and property safety. IT is around data integrity and security. Uh, I'll quickly touch on other two items over here. So on the security priority side, you will see that OT or industrial security usually revolves around safety first. So you have safety, availability, integrity, followed by confidentiality, which is SAIC. And in the IT side, you have the well-known CIA triad, or confidentiality, integrity, and availability. So one other attribute added, and some of the priorities are also rearranged to better fit the model of operational technology. And the reference or security architecture that we like to use on the OT world is called a Purdue model. And I'll briefly talk about that later in the presentation. But it's a segmented network model where you create security zones and divide your assets in a secure fashion so that even if a portion of your network is compromised, you still have pockets that are unreachable um, to the hackers. And in that way, you prevent lateral movements or prevent attackers from going from one part of the network to the other. On the challenges side, there are many. So what I'm listing over here is like 6 or 7 primary ones. And the very first one, and this is because of the Industry 4.0 theme of connectivity, is the convergence of IT and OT. So when your manufacturing line, which was separate from your IT communication, is pushing data to cloud, now you are trying to leverage the infrastructure that IT already has, and it leads to a convergence of two different security teams or two different mindsets. And what happens is it causes a huge security gap. So if it's not done correctly, what will happen is these vulnerable systems that are running the manufacturing line or running the nuclear power plant will now get exposed to threats that they were not designed to face or defend against. So a very, very concerning and important consideration when you are transitioning from a more air-gapped system to a more connected or highly available system that are talking to the cloud. Then IT-OT cooperation. We see this all the time, that the security engineers on the IT side and then the security engineers on the OT side, they have different mentalities. So oftentimes when you go in and create a security program that is trying to unify these two teams, there are certain challenges. And it's primarily because these are two different parts of the world. The OT engineers are trying to keep their system running all the time, and the IT engineer is trying to patch and trying to update the system all the time. So there is a bit of cultural difference, and the priorities are different. So there, it is important as a security engineer to kind of moderate that discussion and align their vision accordingly so that they can work together and create a successful security program. Now, the third one is a legacy system in industrial control system architecture. So we see this all the time. There are systems that may be implemented in the 80s or 90s, have very old PLCs or computers. I have seen XP systems in 98, like even today, we see that all the time. And because they don't want to stop these systems, what end up happening is these systems somehow get connected through uh, different gateways, and they end up getting connected to the IT side. And these systems, or legacy systems, are very, very hard to secure because cannot take security patches anymore. They can only rely on other compensating controls like network segmentation to secure them. Then we have control layer protocols that are difficult to secure. So I talked about Modbus, there is CAN bus. So these protocols are designed for the industry, and these are not designed with security in mind. So it's extremely hard for the security team to come up with compensating controls that can protect or to build security around them. And then quickly going over a couple of other items is you will see a lot of vulnerable industrial assets. That is mainly because patching regularly is not a viable option in the world of OT or Industry 4.0, because you need to keep the manufacturing line running. So you will have to come up with a good patching cadence. And then you sometimes also face the problem of visibility. So when you go to an industrial plant, ask the process control system engineers, a lot of them won't have complete visibility over the entire network. They are more segmented, or I would say zoned around their own processes. In turn, what happens is their security team struggles to get a broader picture of all the connected assets, which is a challenge. And that's why we have a lot of OT monitoring tools that are making its way into the market these days. Those tools can analyze the network traffic and can give you a very good visual as well as very good security posture understanding of what's going on your network. Okay, so why are we talking about this, right? There, something is definitely not right. And you see on the lower side of this timeline, these are a selected number of attacks that have happened over the last decade. So, and this is why, and this is one of the primary reasons that motivates discussions like these. So, Stuxnet, everyone is probably familiar with that. It's a very famous malware designed by nation state, and it was able to compromise, uh, you know, centrifuges that were enriching uranium, and a nation state was capable of leveraging some of the zero-day vulnerabilities of certain systems, and they were able to wipe out entire uranium enrichment facilities. And then over time, you will see many different attacks, malwares. Some systems were like not secured properly. The example would be New York Dam attack that happened in, I believe the timeline is wrong over here. It should be close to 2015. And then you have the target store attack, which the attacker leveraged a connectivity from the HVAC system, and they were able to exploit the other areas. So even if you have, let's say, a IT infrastructure that you're maintaining, there are industrial elements or IoT elements like your camera systems or other components which are placed in your infrastructure and might be vulnerable to some of these industrial elements. So it is very important to secure and segment them in a way that if an attacker manages to compromise a portion of your network, they won't have access or they won't have privilege over other areas. And in 2019, we see 17 known big incident. In 2020, we have 62. And in 2021, we had the very famous Colonial Pipeline hack. Again, some security design flaw as well as governance flaw that went into that attack. Someone was able to get credentials, direct credentials to their facility and was able to ransom that site. It's really concerning, and there are a lot of evidence of compromise as we see over the last decade. On the top side, you see a lot of security directives as well as frameworks that was designed as a protective measures. So these are some good lists that you can go and investigate and would provide guidance on how to secure your infrastructure. So how do we secure it? We talk about defense in depth, a very well-known technique where you're adding blocks of security and security controls. And the main idea is you cascade these different security modules. In turns, what happens is the attacker has to go through multiple layers and has to put in more effort to secure these assets. It raises the cost of intrusion, so it is more difficult for the attacker. A very well-known capability or technology or framework, whatever you would say, um, in the IT space, we use the same thing on the OT side, but the tools and how we do it is a bit different. So, for instance, when we talk about network infrastructure or network segmentation specifically, we follow what we like to call the Purdue model, right? This model was developed by the Purdue University at 1990, so a very old model. But over time, as we add 5G or other advanced connectivity or security elements, you see that we added the blocks in a way so that you have the right security boundaries or right type of security control measures around this network segmentation, around this network zones, to provide the right level of security to these components. I wouldn't go through each one of these blocks, but once you get access to this slide, uh, you will have a good overview of what each of these blocks do and how you can take your industrial elements, or if you are maintaining a manufacturing line, assets in the manufacturing line can be zoned off based on this architecture that we have. And then finally, um, there are a couple of regulations. So we talked briefly about NIST. So NIST 853 is a very well-known um, framework guideline to kind of assess your security posture, as well as it provides you guidance around that. IEC 62443 is again a set of very good standards that provides guidance around that. And then there are NERC and other components as well that provides regulations. So these are some regulatory bodies who produce security frameworks and produce good resources that can be used as a reference to better secure your industrial infrastructure. So key takeaways are, I repeated this a lot of times, IT and OT security are different. Cybersecurity on OT system can cause physical impact and loss of life. IT tools do not always work on OT systems, so we cannot use the active scanner and do vulnerability fingerprinting. That is not advisable, and it will break OT systems. Defensive in depth is still a recommended architecture, and almost I'll leave this present or end this presentation with the statement that if you invest on industrial security, you're basically investing on safety of your people. So when you try to secure a nuclear power plant, basically you're trying to protect the personnel who are working or who are supporting that. So with that, that's the end of this presentation. Um, I know that we are short on time as well. So let me know if you have any questions.